Okay, hello guys, welcome back. Here's our demo of our real-time clock we got going on here. Go ahead and go through the circuit for you guys. We've got the voltage regulator, got our two decoupling caps, we got the power in and ground. As you can see here, we got power and ground. We've got our PIC 1938, 16F 1938 chip. Here's our mem clear. This is going up for our mem clear. Here's our two LEDs through our 470 ohm resistors. Then we also have, power and ground to the chip. But then here, these are the only ones I could find that were actually 3.9K resistors. I want to make a note, I did try the 4.7s, and that was still even a little too much. So you need to be around 4K or a little bit less. So the 3.9s work real well, and these were the only 3.9s I had, were these great big power resistors. But still, those are basically decoupling, or they not decoupling, those are capacitors, but they're basically a pull-up on the clock and data lines that are running over here. See, they pull up to the high rail. This rail is my high rail, so they pull those up. So that's the pull-ups that make it work. And we're gonna see if we can't power this guy up and see if he's going to work for us. So give me just a second. Oh, I also want to mention that when I did the software, there's a couple of software changes, just not a whole bunch, but just a couple. I forgot to when I wrote down the registers to check, I didn't use the array. I just wrote the actual register number. And oh, here we go. Here it's going to go. Plugged it in. And so those changes are made. The code is now reposted and is repackaged, reposted on that project's code link that's on my channel. So you can go to that, and if you downloaded it, I apologize, you can re-download it, and it'll have those changes in it. I also have in the description down below, in the description, I have the lines that actually change, the lines of code that actually change. So you can look for that and see what I did. Those of you that downloaded it before, and you can look at it and see why it's different. But as you can see, it's doing it. It's about a 4-second interval, like we did. We can count here. Let's see. Wait for change. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000. So it's pretty much a 4-second, and it's dead on. That's one nice thing about RTCs, that it is a dead on 4 seconds. Very, very, very accurate with these guys. Oh, and I forgot, if you wanted to see, I forgot to show it to you. Let's see if I can do some zoom action. See, whoa, see if the camera can actually focus this in. See that little bitty guy, little tiny guy, this little guy right here. That's that 32.768 crystal oscillator is what that little guy is. Let me see if I can get this out here. There we go. Boy, doing this and holding the camera at the same time is interesting. But this little guy, that's what that little guy is. You can get him in a bigger package, but for the through-hole one, I got just this little tiny can. But it does fit, barely, but it does fit in a breadboard if you're wanting to breadboard this. So anyway, I'll back up here. But anyway, that's basically it. So I like to show you guys that the code really does work that I'm doing by going ahead and wiring this up, and also it helps me catch things like that variable thing that I was mentioning before, that I had to change it. It helps me catch that way. I know I like feeling confident when I post code for you guys that the code actually does work. You can just straight away flash the chip with it, as long as you have the hardware configured in the way that I show in the schematics that I show. You have the hardware configured that way, then you'll have no problems getting it to work. So anyway, that's pretty much should wrap it up for the real-time clock demo, and basically showing you guys how to implement real-time clocks with CCS. I'm also going to be redoing that 1307, the DS1307 code, or at least that driver for the High-Tech C, so keep an eye out for that. I'll post when I've redone that, and what it'll be is it'll just be another section of code. I don't think I'll probably make a video about it. I'll just post a bulletin that mentions that it's up there, so check the bulletins periodically, as well as check that project code link site for the next rendition. I'll probably name it High-Tech C Lesson 17 RTC or something like that, so that way you know that it's the High-Tech C version. And then those of you that like High-Tech C can actually have a driver for the DS1307. So anyway, that's pretty much all of it in a nutshell. Hope you enjoyed it. See you next time.